Okay, so again, our exam is tomorrow. If you go to the exam prep area, go to the exam 2 folder. This is a comprehensive outline right here, so there's nothing on the exam that isn't mentioned here or wasn't emphasized in class. The web work, many of you have worked on that. Might not quite be comprehensive. It's a big chunk of what the test covers, but there may be some things in this review outline, things we did talk about in class, that there isn't specifically a problem in web work. So web work is good, but it's not 100% complete. Okay, so make sure that you're finding problems from the book, from your workbook, from the homework, that are everything in this outline. Okay, same procedure as normal. You're going to bring your Sun card to the testing center. It's open between 10:30 and 6:30 is when you can enter, and then you can work until like 8 o'clock, 8 p.m. All right, so no time limit. Any questions about the exam tomorrow? Chandler? I am not. So if you have specific questions you want to email me, I'd be happy to get back to you, or sit down with me and we can go over them. But no, I'm not going to put up answers to these. Other questions? Okay, format is similar to what we've seen before. All right, so everything we do today is kind of wrap up for tomorrow's exam. So think of this as part of your studying, okay? Think of this as part of your studying. So let's wrap up polynomials. Here's an example. So last time at the end of class, I gave you the graph, and you came up with the equation, right? So now we'll do one the other way. Here's the equation. You come up with the graph. So for a problem like this, you don't get a calculator, okay? You don't have a graphing calculator because that would be cheating in terms of what we're trying to do here. So what were the different ways that we looked at these, the pieces, the building blocks of, what were the things we talked about that would help us take from this equation and start forming the graph? What was one of the things? Yeah, Jacoby. Okay, roots. So was that end behavior or middle behavior? Roots. Middle, right? So middle, right? Okay, so then we also have end behavior. What else? There's actually 4 things. Joseph. Okay, roots. Okay, so we'll put those together. What else? Okay, so yeah, those all go together. Y-intercept. Yeah, actually, so roots and factors go together, and then the multiplicities is. Okay, so those are kind of the 4 things that help us. Those are the building blocks. Once we get those, then we kind of piece it all together, and we use kind of reasoning to say, here's what this graph must be like for all those things we found to be true. Okay, so I'm going to let you work on it. So take 5 minutes to, without a graphing calculator, see if you can make a sketch of this one. Okay. Remember everything we did regarding those 4 things. Okay, Jackie, you're up. Talk to me about some roots.
Roots, I did, so you set x plus 4 to 0,
Okay.
x minus 6 to 0.
So when you say x plus 4, what is x plus 4? What do we call that? Is there a name for that? X plus 4? A factor, right? And so what's the or the root we get for x plus 4? Negative 4. Okay.
And then there's
X minus 6.
and then
6. Okay.
and then 2x minus 7, and that would be
7 halves. Okay. Let's have Ajane take over from there. Let's talk about multiplicities on these then. What's the multiplicity on x plus 4? Is it 1? So what's the 3, right? What about x minus 6? That one's 1. 2. Okay, and so where do we, so what do the roots tell us about the graph? So like negative, what does this negative 4 mean for the graph, Ajane? What does that give us for in terms of graphing this? Not sure, Renee. Okay, tell me. So what? Like negative 4, like here? To the left. This one? Okay, and then 6. Oh. 6. And where else? 3.5. Okay, cool. Let's let's go to end behavior next. So we got those. So let's do end behavior next because so with the multiplicities it kind of gives us the behavior around the root. But for instance, the 2, we're not really sure just by looking at 2. It could be like this, or it could be like this. Okay, it could be either way. And so we got to do the end behavior work first and kind of work that into it. So end behavior. Joseph, you're up.
So, end behavior we want to draw as x goes to infinity, y would go to negative infinity.
How'd you get that?
Because I got the highest power of the function by taking the constant.
Okay.
And, the highest exponent x plus 4 3, so x 2
Okay.
times x times 2x squared, you get negative 150 x to the 6th.
Negative 4 over 30, or negative 2, or yeah, x to the 6th. Is that what we said?
Yes.
Leading term. So we got to get the leading term to get the end behavior. And you should have gotten negative 4 over 30 or negative 2 over 15, x to the 6th. And so x goes to infinity. Is that the right end or the left end?
It's the left end.
The left end. Joseph, you agree with that?
Yeah.
Wait, no.
Right.
Changing your mind?
It's neither.
And that's one of them. This is end behavior, so it's either way out at the right or way out at the left.
It would be to the right.
This is the right. Large values of x would be going out here for very large values of x going this way. Okay, and you said y goes to? Yep, that will do negative.
Oh, I didn't see that there. The x.
Okay, and then left. So somebody new. Left end. How do we represent the left end? Alec. Negative infinity, that's way out the left, okay? He also wants negative. Agree with that? Want to go over it? So you put a large negative to the sixth. Start with the x term. A large negative to the sixth becomes what? Positive or negative? Positive, but then we're multiplying by a negative. In the end, negative. So we're going up or down to the right. When we go right, we go down. When we go left, we go? Okay, so we know this is the last root to the left. So after it goes through -4, it's going to go down. And this is the last root to the right. So after 6, it's going to go down. This. Okay, let's get this. Anybody get the Y-intercept? Let's see. Hamid, did you get the Y-intercept? How would you? You know how you would get it? What's true about the Y-intercept? So what do we know for sure about the Y-intercept? X equals 0, right? So how can we find it? Yeah, just do x equals 0. So the Y-intercept on the y-axis, x equals 0. So if you put in the equation, it just agrees in the equation, x equals 0. So we're going to put 0 in. I'll do this in red. It's too messy. So we're going to put 0 in. We're going to get -1/30 times what? What will this be?
4 cubed.
4 cubed times
-6.
-6 times -7
Squared.
squared. Anybody get a number for that? Tell me. 627.2. Somebody else get that? Thumbs up. 627.2. And so, right there. Y-intercept. Okay, so now all that's left is to kind of put this all together with the behavior using the multiplicities. So at 6, is it going to go through or stay on the same side? So do we look at the multiplicity? Multiplicity of 1 means what kind of behavior? Linear behavior. It's kind of like x minus 6. So going to go through or stay on the same side? Going to go through. And going to go through straight, kind of like a line. And then here at 7/2, 3.5, multiplicity is? So somewhere it's got to get back to, it's not going to cross anywhere through here. There's no roots here. So it's got to get back to 2. And then what's it going to do? It's going to be like a quadratic function or a parabola, right? So, something like this. Let's try again. All right, a little better. Okay, then what's next? Yeah, there's no roots here, and the next thing, so it's got to go through the y-intercept. Something like that. And then how will it go through at -4? Multiplicity of 3. Straight through? No, so it'll be like cubic behavior near that root because x plus 4 is raised to the 3rd. Okay, so cubic behavior it comes down steep, but then it flattens out, then it goes through. So this is our kind of attempt, putting everything together. We got the end behavior, we got the y-intercept, we got the roots, and then what happens near the roots. Anybody have a question? So, the moment we've been waiting for. Let's turn it on, see how we did. Okay, so we got it. So everything is generally what we did. But theirs is a lot prettier. Let's turn it off and just look at that. Okay? So now I want to ask you some questions about this graph. Okay, go, discuss. So these are you're just estimating. So you're estimating just by looking at the graph. For what x values is the y quantity increasing? For what x values are changes in y decreasing? Changes in y. Okay, so this is for small equal changes in x. And then for what x values is the rate of change increasing? Go, discuss. Question, yeah.
Is y increasing at
Is what?
is y increasing at that 1 point?
If you went a little bit to the left from that, it would be less than, right? And if you went a little bit to the right, it would be greater. So is it increasing at that point? If you went just to the left of -4, like -4.0001, would the y value be less or greater? Over here. Less. And if you went to -3.99999, would the y value be less or greater than this? Greater. So you tell me, is it increasing through there or not? You told me it was. You told me the y value was less than 0, then greater than 0. Increasing. Make sense? If it wasn't increasing, then there would be 2 points that had the same y value. And that's never. Yeah, yeah. Right? How else could it be not increasing? If it's not increasing, you're telling me there's 2 points that have the same y value, right? Can't be. Yeah.
Is it 1.6 y decreasing?
What's that?
Is it 1.6 decreasing?
Is what decreasing?
1.6.
1.6 is an x value. It's always 1.6. What do you? So you got to clarify your question. The line.
Yeah.
Are you talking about the y value?
Yeah.
You're saying as the y value decreasing at 1.6?
Yeah.
There shouldn't be any question in your mind to answer that question. So why are you confused about that? You're asking me if y is decreasing here. Are you asking about the rate of change?
Yeah.
You're asking about the rate of change. That's what I thought. Okay, so it sounds like, although, so I gave some estimates here of some key points. -4, -3/2, 0, 1.6. Oh, we got 3.5. And maybe this is 5.3. Let's be consistent here. -1.5. Okay. So what do you think? For what x values is the y increasing? Okay, so there's going to be intervals. There's going to be intervals. So for what values is y increasing? Ginger. Okay. Okay, she wants -4 to 0. What about over here? Is y increasing there? Okay? Negative infinity to?
What's negative?
You said, at first you said negative 4 to 0.
Yeah.
And then I asked you about this over here. So can you put it all together?
Oh, negative infinity, negative 4.
Yeah, so but you can just say it all of it in one interval, you see?
Oh, okay, negative infinity is 0.
Yeah, negative infinity to 0. Is that it?
And no. Then 3.5 to 5.
What do we think? Hopefully that's an easy question. Anywhere else? Where y is increasing? Yeah, Peter.
Just a question about the trip to 0.
Yeah.
At the point negative 4,
Okay.
is y actually increasing?
Okay, so if it's not increasing, then it's got to be doing. Then you've got 2 points that do one of two things. Either you got 2 points where the next point over is less than, or the next point over is the same. So are there 2 points that have the same y value there? No, because it's always less than, and then it's 0, and then it's always greater than. So it's still increasing. Even though it flattens out for one moment, you're always less than 0, then always greater than 0. So that is still increasing through there. Other questions about, that should be easy. Okay, what about changes in y decreasing for small equal changes in x? Okay, this is where it gets trickier. What do we think? Where are the changes in y decreasing? So let's start here, from negative infinity to negative 4. Are the changes increasing, staying the same, or decreasing?
They're decreasing.
He wants decreasing. Agree? Yep, because like look, for small equal changes in x, the corresponding change in y gets less and less each time. Okay? So yes, this check. What about from negative 4 to 1.5? Are the changes in y decreasing or increasing? Increasing. Nope. Okay? What about from negative 1.5 to 0? Are the changes increasing or decreasing?
Decreasing.
Decreasing. It's just like this, right? Okay. What about from 0 to 1.6? Changes in y decreasing or increasing?
It's getting more negative.
All right. So for equal changes in x, are the changes in y increasing or decreasing?
I think they're getting more negative, so they're decreasing.
Okay, so I heard increasing, and then I heard they're getting more negative, so they're decreasing. We better get this straight. This is what confuses students. So, the amount of change is getting greater, but the changes are negative, so they're getting more negative. Values that get more negative are decreasing. The changes are decreasing. This is confusing because intuitively you think, oh, those are getting bigger. No, but they're getting bigger negative. So the changes are decreasing. And so what do we have here? All through here where the changes are decreasing, getting less positive and more negative, what did we call that with a graph? Changes are decreasing means the graph is concave down. Wherever it's concave down, the changes are decreasing, whether they're becoming less positive or more negative. Okay? So this part through here, all the way from 1.6 to 4.5, the graph is concave.
Up.
Therefore, the changes are
Increasing.
increasing. Changes are increasing. Because here the changes are getting
More positive.
not more positive, less negative there. Those changes get less negative. That means they're going up. And that's why concave up means the changes are increasing. Same with here. So then what about from 4.5 to infinity? From 4.5 to infinity, always it's concave down, so the changes are decreasing. All right, so we got negative infinity to negative 4, negative 1.5 to 1.6, and 4.5 to infinity. Ask me now if I lost you or you're confused. Negative 1.5 to 1.6. And what's the other one? 4.5 to infinity. Questions on question number 2? Yeah.
So to be clear, whenever it's increasing at a decreasing rate, that's when it's.
I'm not crazy about the phrase. Split it up. So the graph, you want the graph to be increasing.
But if it's increasing in the rate of change in a negative way, correct? Or am I getting that wrong?
Is it increasing or decreasing or decreasing?
Okay, try me one more time.
Okay, so technically the rate of change is increasing, but it's
Where? So where are you talking? Where are you looking?
on 0 to 1.6.
0 to 1.6. Awesome. Okay. 0 to 1.6. So first we say, what are the changes doing? The changes are they increasing? Yeah, see, that's what's confusing. They're not increasing. The changes are negative, and they're getting bigger and bigger negative. So if I gave you this list of numbers, these are, sorry. Are those numbers increasing or decreasing? They're decreasing. Decreasing. And that's exactly what these changes are doing. They're negative and becoming bigger negative. So those changes are decreasing. Therefore, the rate of change is decreasing because the rate is becoming more negative. And that agrees with what we call concave down. Whenever it's concave down, the rate of change is decreasing. Changes are becoming more negative. Does that answer it?
Yeah.
Cool. All right. So then where's the rate of change increasing? Where's the rate of change increasing? If in these sections the changes are decreasing, where's the rate of change increasing? In one simple phrase. What's that?
This is that where the y changes in y increasing. But this is that is not where
Right. So if this is everywhere where the changes are decreasing, where's the rate of change increasing? You can do it in 2 words. Everywhere else, right? Everywhere else. Everywhere else. Okay? So where's that? I'll do it in red. Rate of change increasing, right? Rate of change increasing or decreasing?
Increasing.
Increasing. Ah. Thank you. Okay. Hand off the button. Okay. Rate of change increasing or decreasing? Increasing. Rate of change increasing or decreasing? Increasing. Concave up. Anywhere it's concave up, the changes are increasing, and therefore the rate of change is increasing. Changes in y are increasing, getting more positive or getting less negative, therefore the rate of change is increasing, and that's concave up, where I've drawn red. Questions on this example? Chandler first, and then, yeah. What's that? It's basically covariation. Covariation and analyzing the covariation of 2 quantities. How y and x change together. Yeah.
We always cut the graph in half right there.
Wherever the concavity changes and wherever you have high points and low points. So the high points and low points are going to mark off where the y quantity changes from increasing to decreasing. So like here, and here, and here. And then wherever the concavity changes is where the rate of change changes, right? So the concavity changed from concave down to concave up. So here the rate was decreasing, and then you got this point, and then the rate is increasing. Yeah. So the whole thing all the way to the top is just about the y value, always increases. But the rate at which it does is changing. It's decreasing, and then increasing, and then decreasing. The rate. Okay? Other questions? Okay, in your book, look at number 5. page 195, number 5. So this is an ice cream shop finds its weekly profit. It's a function of the price measured in dollars. And so it's a polynomial, and specifically, it's a quadratic function, meaning that the highest power of x is 2. So it makes a parabola. So this one is a good one for using your calculator, which you should have a graphing calculator for the exam tomorrow. You should have a graphing calculator for something like this, okay? So we've got this profit. So we got it, before we do anything, we got to know what does our x quantity represent and what does our y quantity represent. So if we read the problem, it says that the weekly profit measured in dollars as a function of the price it charges per cone. So x quantity, so on our x-axis, what do those values represent? According to what it said. Someone has said price of a cone. Agree with that? Yep, x is price of a cone. What's our y quantity?
Weekly profit.
Weekly profit, and then is that in, what's the unit for that? In dollars? So this is a common thing that you'll have in your calculator. You'll put a function in, and it will just give you vertical lines, or nothing. You'll see nothing at all. So this is a matter of really understanding the quantities that you have and finding the right window to show the graph, right? So what do I need to show this graph better? What should I do?
Down.
Okay, zoom out. Just zoom out on the whole graph?
The Y-intercept.
Yeah, I'm going to just zoom in on the y. The x is pretty decent here, right? So we can see the dollars per cone. You're not going to pay $10 for an ice cream cone, right? So it looks like the y-axis is pretty decent. It's just the weekly profit. So we're going to zoom out on the y. So you should know how to do that on your handheld. Okay, so now we got something that maybe might make sense. Okay, so how would we determine, so let's go through the questions here. Determine the maximum weekly profit and the price of an ice cream cone that produces that profit. So see if you can do that. That's a good question. If the cost of the ice cream cone is too low, the ice cream shop will not make a profit. Determine when the ice cream shop needs to charge in order to break even. Okay, find that point. If the cost of the cone is too high, no one will buy it, and your profit will be 0. Determine what the ice cream shop should have to charge in order for this to happen. Okay, so do questions A, B, and C as written in your book. Go. This is practice with your TI. So you should be able to answer these questions using your graphing calculator. Question?
Yeah, on the last one.
Part C?
No, the last problem number two.
Oh, yeah.
Is the vertex of the parabola always going to be a y-intercept?
No.
No.
Like we said, there was another one over here, right?
Yeah.
That was just on that particular problem. And it might not even have been. We just assumed it was 0. It might have been like 1 or 10 or -2, or it didn't have to be right there.
Oh, right now.
So we just, it looked like it, so we just assumed it just for answering the other questions.
Okay.
Is that good?
Yeah.
If you get done with those 3, I got 3 more for you. Important questions. So I'm going to put up answers to A, B, and C in the book, and you can check, but then you want to work on Roman numerals 1, 2, and 3. Very important questions for the exam tomorrow, okay? You got to know this stuff. This is a review. Okay, but got to know it. Okay, questions on A, B, or C? Can you answer A, B, or C? So it's about really attending to what is X, what is Y. Keeping always X is what? Price of a cone. So your X coordinate will always be price, in this case, price of a cone, and your Y coordinate will always be your weekly profit. So in A, B, and C, I think they're asking about these 3 points. So how would you find the increase in price of a cone from the break-even point to maximum profit? How would you find the... Okay, so I don't want to... I'm going to end up keeping you over, so let's try to get out of here as soon as we can. So how would you find the increase in cost of a cone from the break-even point to the maximum profit? How would you find that increase in cost of a cone?
You subtract the or the maximum profit price from
So what would you tell me the numbers?
268 minus.
Right, so you take the price at the max profit, 268, and you'd subtract the break-even price of 19 cents, and that would be the increase in price corresponding to break-even to max. Okay, number one, what's the meaning of the value computed by K3 minus K1? What would that number mean? Got to know this. What would that, if you took K3 minus K of 1? Travis.
The change of profit from $1 of cost of the cone to $3 of that the cone cost.
He said the change in profit when the cost of a cone goes from $1 to $3. Perfect. Excellent. Second one. What expression would represent the change in profit for increasing the cost of a cone by 50 cents if the starting cost was $2? Somebody knew. How could we write an expression? Evan. Okay. Nice and loud. You done? Is that it? So we want the change in profit.
Oh, minus whatever the minus K plus K2.
Is this your final answer? What about that? Change. So here's the this represents the profit at $2.50. That's the profit at 2. So this is taking the final profit minus the initial profit gives you the change in profit from when a cone is $2 to when a cone is $2.50. Okay, last one. The average rate of change of profit for a change of cost of H dollars if the cone price starts at X dollars. You've got to be able to do this. What would that be? Can you do it? See if you can do it. If you haven't tried yet, go. Take it 30 seconds and we'll be done. You've got to be able to write this. The average rate of change. So here we are at X. And then here we are at X plus H. Or H. So then we're going to have an increase of H. And we want the average rate of change, which is the constant rate of profit with respect to cone price. So how do we write that average rate of change? Somebody on this side. Jack, think you can do it?
Yeah, it's k of x minus, or k of x plus h minus k of x
Okay.
over k of x plus h, or k of x plus h.
Over X plus H. So what does the bottom represent? This is the change in profit over the change in
Over h.
price. So just H. Change in profit over the corresponding change in price gives you the average rate of change of profit starting at any cost X and then having an increase of price of a cone of H. Okay, to get the bonus for the web work, you got to be done by 9 p.m. Then after 9 p.m., it's all still available, but the answers are there. Okay?
Do you have to have all web versions?
No, you can. It'll be prorated. Yeah. If you do half of it, you'll get half the bonus. Exam tomorrow. Don't forget.
For the test tomorrow, we have until like 6. You said, right? Or
You need to get in the door by 6:30.
okay.
You can work until 8.
Oh, okay. Thank you.
You're welcome.
Could you explain what k of 3 minus k of 1 was again?
So let's just do K of 3. What is K of 3?
K of 3 is the price of a cone being $3. No,
Not a price. 3 is the price of the cone. What is K of 3?
it's the profit
Profit for what?
for the value of a cone being $3.
The weekly profit if they
They charge.
charge $3 a cone.
Okay.
So what's K of 1?
K of 1 is the profit of charging, the weekly profit of charging $1 per
So what would that difference be then? If you had the profit for charging $3 and you subtracted the profit for changing $1, what would that mean?
Yeah, it's the weekly profit.
We're gonna study it.
So let's do it. So for 3, say the weekly profit is $750.
Okay.
And,
750 minus.
and so 1 for 1, I'm just guessing it's 400, okay?
Okay.
So what we're calculating here is the weekly profit for $3 cone versus weekly profit for $1 cone,
Okay.
which is $350. So what does that number represent?
That's the increase in weekly profit for charging $3 instead of 1.
That's right.
Okay.
For increasing, if you increase the cost of a cone from 1 to 3, it's your change in profit. It will go up $350.
Okay.
You see?
Professor,
Yeah.
I had a question about the Math 270 class.
Yeah.
Like, how different is it like to 265 calculus for engineers?
Well, the content is about the same.
Okay.
It's just the approach in the class that I'm going to be co-teaching is going to be like this.
Okay.
And then in 265, it might feel a lot more like math classes you've had in the past,
Okay.
where it's a lot more just exercises and a lot of algebra. And so the one that we're doing will be a lot more focusing on meanings and reasoning and
Questions
understanding
why.
quantities. questions of y and questions like this,
Gotcha.
and representation of quantities using functions. And
Do you know what the instructor's name is?
I can give you the line number. I'll do it right now. Can I erase?
Yes, that's fine.
Do you have a question about this? Anybody have a question about what I have written up there? Okay.